The Hodge conjecture is one of the 7 Millennium Prize problems in mathematics, for which the Clay Mathematics Institute offers a $1 million prize for a correct solution. It's a deep question in algebraic geometry, a branch of mathematics that studies geometric shapes defined by polynomial equations. To understand the Hodge conjecture, we first need to understand a bit about algebraic geometry and topology. In algebraic geometry, we study shapes, called algebraic varieties, that are defined by polynomial equations. For example, the equation x2y21 defines a circle, which is a simple example of an algebraic variety. In topology, we study shapes in a more flexible way. We consider shapes to be the same if they can be stretched or squished without tearing or gluing. For example, a circle is the same as a square in topology, because you can stretch a square into a circle. To keep track of the different parts of a shape, topologists use tools called cohomology groups. These are mathematical objects that, roughly speaking, count the number of different holes of different dimensions in a shape. Now, when we have an algebraic variety, we can look at it both from the perspective of algebraic geometry and from the perspective of topology. This means we can look at its cohomology groups. Some elements of these groups come from algebraic geometry, from something called algebraic cycles, which are subvarieties of our original variety. The Hodge conjecture is about identifying which elements come from algebraic cycles. More specifically, the Hodge conjecture is about a certain type of cohomology class, an element of a cohomology group called a Hodge class. These are special elements that have extra structure coming from complex geometry, a branch of geometry that deals with complex numbers. The Hodge conjecture says that every Hodge class is a rational, linear combination of cohomology classes of algebraic cycles. This might seem like a technical statement, but it has big implications. If true, the Hodge conjecture would give us a powerful tool for understanding the shapes of algebraic varieties. It would tell us that certain topological features of an algebraic variety always come from its algebraic structure, which would be a deep link between two different ways of looking at the shape. Despite many years of effort, the Hodge conjecture remains unproven, and is one of the biggest open problems in algebraic geometry. Solving it would be a major breakthrough, and would greatly enhance our understanding of the shapes defined by polynomial equations.